Hi, Geometry. As a reminder, yesterday as we started triangles, we talked about the triangle sum theorem and how every single triangle in the world, the sum of the three angles is 180. Okay, so today we're going to kind of examine triangles, look at some vocabulary words about them, and keep developing our knowledge of them. So, first thing here, a triangle. I'm guessing you guys know this, but the triangle is just three sides all connected. Okay, now the vertex or the vertices are each of these corners here. Okay, so the green dot is the vertex or the plural, the vertices. Okay, and each of those is where one of the angles occurs. Now, an interior angle. Hopefully, this sounds like inside to you. So, if we have an interior angle, it's going to be when we have either right there, right there, right there. Okay, it's on the inside of that triangle, between the two sides. Then you also have your exterior angle, and this occurs on the outside of the triangle. If a line would continue as it does here, an exterior angle is formed on the outside. Exterior sounds like exit. Think back to last chapter when we had interior and exterior, alternate interior, alternate exterior angles. And so right here it's on the outside, but it's in between still formed an angle. Okay, so a couple of vocabulary words here, and now we're going to keep going. Sometimes we're going to classify our triangles by sides. And what this means is we classify it based on how many of the sides are congruent. Okay, so we have to learn some words. So equilateral triangles. Okay, hopefully equilateral sounds like equal to you at the beginning. So this is when we have three congruent sides. So all of the sides are the same. So remember, congruent means they are the same length. So an example of this, if I draw a equilateral triangle, and the way I can show they're the same, I put a little mark here. 1, 2, 3. Those are all the same because they each have one mark, tells me they're all the same. Now, if I was actually going to measure that, I mean, I drew it by hand, so it might not be perfect, but roughly each of those sides is the same. Okay. Now, isosceles triangle. Some of you probably already know this, but instead of three congruent sides, this is when there are only two congruent sides. And an example of this, let me redraw that. That's not my best. So I could just put a mark here and here. This third side down at the bottom is not the same length, so we can't put a mark on it. Now, if you wanted to distinguish these two triangles between each other, since I have one mark here, I can just simply have two marks instead. The key is wherever the marks match up, that's where they're the same. So 2, 2, 2 right there, those ones go to the same. If my indicator here, 2, 2, 2, or over here it's 1 and 1, so those go to the same. Okay, if I wanted to draw another triangle that had congruent sides, we'll do another isosceles, and I could do 3 with 3. That tells me that both of these are the same, but we don't know necessarily how they compare to over here. Okay, the final one then, congruent or scaling triangle, is when there are no congruent sides. Okay, some of you might have been tempted to say one congruent side, which does follow the pattern, but it doesn't really make sense because in order for something to be congruent, it means that they're the same. So if there's one congruent side, of course each side is the same as itself. Okay, so no congruent sides. Example of that. Something like that. All three sides are different in length. Okay. So these are the ways we can classify triangles by sides. Okay. So the three ways to classify triangles by sides: equilateral, when all three sides are the same; isosceles when two are the same, and scalene when none of them are the same. Now, let's look at the other way we can classify triangles, which is based on the angles inside of the triangle. Now, as we said yesterday, we already know that all three angles have to add up to 180. However, the way they do that can change from triangle to triangle. So if it's an acute triangle, this means it has three acute angles. All three angles are acute, which means all three angles have to be less than 90 degrees, okay? And so if that's the case, maybe this one's 85. This one is 50. And if that's the case, 85 plus 50, we know gives us 135. So we can take 180 minus that 135, and we find that that last angle, the only way it's possible is if this last angle is 45. Okay, so an acute triangle is when all three angles are acute. They are all less than 90. Now a right triangle, this is when you have one right angle. Now some of you might have been tempted based on the last one. It was acute triangle, we called it three acute angles. So a right triangle you might say has three right angles, but hopefully you can think about it, and that's not possible because 3 times a right triangle, right angle is 90, 3 times 90 would be 270, which is too big. So it's got one right angle, and hopefully you remember, in order to mark a right angle, we can just put a little box. And remember, right angle means it's equal to 90 exactly. Okay, so now let me scroll down a little bit. For obtuse, okay, an obtuse triangle is when we have one obtuse angle. So an obtuse angle is anything that is bigger than 90 and less than 180. So this would be an example of an obtuse triangle. My lines are not perfect, but say that's 110 degrees. Okay, it's obtuse angle, which means it's an obtuse triangle. And our final one sounds very similar to equilateral on the front, except instead it's equiangular. Okay, this is when we have three congruent angles. All the angles equa angles. Equiangular means equal angles, so three congruent angles. Now think for a second, if every triangle adds up to 180, and all three angles are congruent, that means we can take 180 divided by 3, and we'll find that each of these angles would be 60. Now I can mark them each with one of those. They are all the same. Also, just so you know, if it is equiangular, it is also going to be equilateral. So, once again, if we are classifying by angle, we have an acute triangle, which has three acute angles, a right triangle, which has one right angle, an obtuse triangle with one obtuse angle, and equiangular triangle that has three congruent angles. Now, an equiangular triangle is an example of an acute triangle. However, it's more specific in that all three of them have to be the same. Okay, so hope you guys have a great day. Try the review, and if you have any questions, please let me know.